Thermal efficiency and movement. This is another area which is not given enough consideration during the design stage. So especially when we're complying with Part J, Part J requires us to have R3.2 and generally 100mm blanket at full depth underneath a light coloured roof will comply with R3.2. If we were to use a dark colour, then a lot more bulk insulation is required. And so therefore during the design stage, we need to know what colour we're using to make sure we have the right thickness insulation is used. We also get a lot more thermal movement out of our darker colours. So our darker colours therefore requires more expansion joints, and the manufacturers actually limit the length of the darker colours. So a light coloured sheet can be installed up to 24 linear metres, but a darker coloured sheet can be as little as 15 metres long. So it is very important during the design stage that we know what colour, so we can get the appropriate R values and the right amount of thermal movement out of the products that we're using.
Flashings and cappings. If we've got dark coloured cappings, they have a lot more thermal movement, especially cappings with very little profile in them. So if it was a deep capping, say 250mm long, it's going to get a lot more oil canning and buckling in it. So more thermal movement allowance is required on our darker colours, on not just our roof sheeting, but our flashings and cappings. This is a thermal efficiency. This is the ICANS book. I keep this on my front screen, and it's where it's so easily accessible. There's an upload there, which for you can. It's a free handbook. Inside that handbook, there is multiple details, about every detail you could possibly come across. I think underneath a metal roof in a residential situation. So that's cathedral ceilings, without ceilings, with trusses, direct rafters, and it gives you a range of products and gives you an R value on just about every one of them. So it's a very handy book, and it's well worth keeping handy. While I am talking about insulation, I want to touch on sisolation directly under metal roofs. When sisolation is installed directly underneath a metal roof, it should be installed sagging, and it's best installed underneath the battens, so there's a 40mm air gap. If it's installed directly underneath the roof sheet, the condensation will merely form on the bottom of the sisolation paper because it's actually touching. It's the air gap that creates the R value. So it's if you don't, you can always jump onto the manufacturer's sites. They have details and installation instructions, and it's well worth doing. Thermal movement of steel. I've added this one here to give you a bit of an idea of actually how much steel moves. So a 5 metre length of steel with a say a 50-degree temperature change will actually be moving by 3mm. So as the sheet gets longer, that thermal movement increases quite a bit. So it doesn't take much to shear a rivet off or have a joint failure when you're getting that type of movement. So make sure we always allow with thermal movement on everything we do. We have a piece of a steel roof sheet or a flashing. Stop it short by 20mm, always at the top. So it just gives you that little bit of allowance of movement. Box gutter, don't push it hard against the wall, keep it off 10mm, so there's a little bit of thermal movement. Just keep thinking about thermal movement all the time. Expansion and contraction of metal sheeting. So this one includes steel, aluminium. As you can see there, aluminium expands nearly double of steel. So if you're going to be installing aluminium roofs, have a really good read of manufacturer's instructions, as it is a whole new world. There's special tools required to slot the sheets, so that there's slotting around the screws when the sheet gets over a certain length. So yeah, keep aluminium on the top of the list to have a good thorough read of manufacturer's instructions. It's not often used, and so because it's not often used, try and seek out a specialist in that area that's used to dealing with that product. This is one's basically just our basic flashing joints. Okay? Whenever we join ColourBond together, we use this method. So whether it be a valley, a ridge cap, a basic flashing, a box gutter, this is the method to join it. So when we join our material together, we place sealant in the line of the intended fasteners. Then the products come together and then they're fixed at 40mm centres. And then we wipe off the excess sealant. The reason we wipe off the excess sealant, especially in flat areas, the sealant creates ponding and immersion, and quite often that leads to corrosion and early failures. Don't forget to overseal our rivets though, unless blind rivets or solid fasteners are used. On the bottom left hand corner of this slide, I've got those aluminium bonded washers that I talked of previously. So they're tremendous when we're used for flashings. An oversized hole can slightly be used to allow that thermal movement, and then these aluminium bottom washers fitted under every screw. And don't forget to, you may have to allow a little bit more length to those screws as well when using those washers. Thermal movement and effective cover on flashings. So the minimum cover for flashings and cappings for steel roofing is 150mm. So when the flashing covers the roof sheeting, that means that the flashing doesn't have to be 150mm, it has to cover the sheeting by 150mm. So typically when we allow for thermal movement, we keep the sheet off the structure by a little bit at the top. That means our flashings has to be at least 170mm or longer. When a flashing runs parallel with the roof sheet, it must cover the roof sheet by 2 ribs. Now, a lot of the manuals say 150mm, but as the ribs spaced differently on different profiles, 150mm doesn't really work. General rule of thumb, always, as an absolute minimum, flashings always must cover 2 ribs. If a leaf or something like that becomes lodged as a weld between the turn down at the rib, the water running down against the rib hits the leaf, splashes over the rib, and if there is no dry pan underneath the rib, we've got water ingress immediately. So that's why we always cover 2 ribs. It also allows for a bit of water concentration. The water flowing off that apron even is going to provide water concentration to the adjacent rib, doubling up the water in that pan. So by covering 2 ribs is an absolute must. Here's a couple of pictures of some non-compliant jobs that I've inspected. The bottom right hand picture there shows an apron flashing which has been installed hard against a duct and then sealed against the top. That's non-compliant. Apron flashings must always be installed with a 20mm gap against all penetrations. That's the roof sheeting and the flashings, and then a separate overflashing to allow for that thermal movement. On the side of the duct, we must always cover 2 ribs. This duct wasn't parallel with the roof sheet, so therefore by the time we got down to the duct, we didn't have our 2 rib cover. The skylight at the left, the roofer never cut the battens out prior to installing the skylight, and never installed a batten underneath the flashing. So when you stood on the sheet below the skylight, it was very spongy underfoot. We've got, on the right hand side, we've got some roll top ridge there which is not neatly mited together. Looks very poor. On the left hand side there's a very poor selection there of the location of where the vent pipe came through the roof. After installation of the vent pipe there, they could have easily extended the apron flashing down past the vent pipe by 150mm and then installed the Dectite on top of the apron flashing. On the left hand side, I've got a paravet capping coming in junction with some roof sheeting there. The flashing's been scribed to the profile of the roof and filled up full of silicone. A little bit of thermal movement, that silicone will just split and we'll get some water ingress there. There is no doubt. And we've got in some ponding sitting on top of the capping there. On the right hand side, there's 4 or 5 pieces of flashings coming in to flash between the ridge capping and that wall there. Flashings are available. They can be ordered tapered in any shape. Almost, if you can draw it, they can fold it. So every piece of flashing should be folded to suit the position to minimise laps, joints and any holes On the left hand side, I've got the capping once again where it coincides with the custom orb roof. Either the custom orb's a little bit too long there, or the capping has been pushed down to the left. We've got some immersion and ponding there. You can see the dirt starting to already form. The roofers were on site when I inspected this job, so it's not very old at all. As soon as the dirt builds up, it retains moisture, and away we go, the process starts. So the longer that job goes on, the more dirt will gather there, the more moisture it will hold for longer, and the faster it will rust out. Just on the end of that capping there, we can see it's been fingered back into the roof sheet again. Depending on the length of that sheet and how long it's going to move, how quickly that will fail, but ultimately we'll get a failure at that point. Metal battens. Metal battens are typically used now on majority of projects. Timber battens haven't been used frequently. Typically we install them at 900 centres. When what I want to touch on here is we want to have a great consideration of roof traffic. So it's becoming very, very popular now to put solar panels on our roofs, and the solar panels run down maybe within half a metre of the gutter. It's typically where they start. If the bottom batten's within 900 mil at the bottom, that gives you nowhere to walk. So you're walking now, no one wants to walk right on the edge of the gutter for the fear of falling off, so they're going to walk in a bit, and they're going to be walking right in the middle of that mid-span of that batten. That's going to create a lot of roof damage. It's going to create failures in the roof. So if there's solar going on the roof, be very mindful of where you locate additional battens. Also, you might have an area that the gutters need to be cleaned out regularly. It might be a leafy area. So you're going to walk along parallel with the eaves gutter to clean your gutters out. And once again, an additional batten might be a very good area. So if you're in a roof where there's possibility of fires, you need to make sure that the eaves gutters are well cleaned. While I'm on the fire-prone areas, we need to install, it's in the Construction Code of Australia, you need to install an infill strip and close off all your gaps so you don't get sparks or fire entry at your gutter line underneath your ridge caps in those areas. So option 1, roof trusses installed and secured at spacings not exceeding 600. So if our roof trusses don't exceed 600, we install our battens at 900mm centres. Roof framing members at greater than 600, we install an additional safety batten in between our battens. This is for safety of the roof installers and the batten installer. So these must be done progressively from the bottom up to create a safe environment. There's no use going and installing your main roof battens and filling it in between. Once again, when we're doing existing roofs, we have to change our batten spacing to suit the current standards. Also, if we need to changing roof profiles or thicknesses of our roof profile, we have to make sure we upgrade our roof battens to suit the currently installed product. Fastener types, they've come a long way now over the years now. We've got fasteners, we've got class 5 and class 4 screws now. The coatings on these screws we're talking about here is the different class of screws. So our screws are lasting a lot longer than they used to be. But it's very, very important that we use good quality screws. Some of our cheaper imported screws have not got the same coatings as some of our localised screw manufacturers. So the first thing we need to do is make sure we choose the correct coating on our screw. So when we're using Colorbond Ultra, our severe Colorbond, which we use in our severe marine environments, then we must use a minimum of class 4. There are class 5 screws available as well, however they have not got the same range as in the class 3 and class 4. So the next thing we need to do is work out what we're screwing into. So we're screwing into a metal batten, we could be screwing into timber, we could be screwing into steel of varying thicknesses. The timber is pretty easy, that's a type 17 straight out. A metal batten, there is actually a metal batten tech now, which is specifically designed for metal battens. So it increases the pull out when you're screwing into metal battens. Then we've got our steel, so we can be screwing into steel up to 5.5mm thick with our Series 500s, so they've got a very long cutting bit, and the drill hole size is almost the same size as the thread, with a very fine thread. And as the steel gets thinner, the coarseness of the thread gets more coarse and the drill size becomes smaller. So it's very, very important that we get with the right screw that's drilling into the right steel. Then of course the length of the screw, that obviously comes into play. The factors that are considered there are the insulation, the depth of the profile. If you're using insulation, especially very thick insulation, then you need to have a longer screw. The roof profile, if you're fitting an aluminium bond washer, you'll need to go up to a longer screw. So to sum this up, roof profile, length of the screw, and the thickness of the steel or timber that you're screwing into. There's also screws designed for specific profiles. We've got Mini Coro. They have a designer head, which is a very special head which is designed specific to those profiles. There's also security screws which we use on some of the police buildings and high security areas. They'll have a special screw designed specifically for security. There's also screws without neoprenes. These are designed for fixing of roof battens and other areas. There's actually a Pacific batten zip now, which is designed for specifically affixing a metal batten to timber trusses, and also a Tech there, which is designed for fixing metal battens to steel frames. In our cyclone areas or our class cyclonic areas, we fit our screws with a cyclonic head, and some of those heads are designed for specific profiles. So if you are going to be installing in a cyclonic area, grab the product data for that specific product, and it will have the recommendations on there for the correct length screw and the cyclone assemblies. Polycarbonate and fiberglass, they have very specialised screws and fixing methods as well. Polycarbonate has a lot of thermal movement and should be be installed very carefully. If you're installing any polycarbonate, read manufacturer's instructions and follow it to a T. And also, one thing to note very carefully with polycarbonate is that you have to be very careful what sealant you use. There's some sealants will actually eat the polycarbonate, like corrosion, very quickly. Fiberglass is it's not as susceptible to movement as much as polycarbonate is, but once again, you have to be very careful. It moves double what a metal sheet does. So when you're fixing fiberglass, you have to use a special fiberglass Tech. It drills a hole. There's a wing in the head of the screw. It's actually part of the screw. It drills the hole for you, and then the wing drops below the actual fiberglass sheet, and then it leaves just the shank of the screw and in the middle of the hole, allowing for that thermal movement. So the fiberglass Techs are available in 2 lengths, and so make sure you get the correct one for the correct profile. Underneath while I'm on the fiberglass, as I said, it moves a lot, so wherefore we end lap that. We end lap it with a lap seal tape, and 2 runs of lap seal tape, approximately 150mm apart and 25mm from the end of the sheet, and make sure the end of the fiberglass sheet doesn't extend past the screw by no more than 150mm. Side lap tape is normally used on the side laps and the end laps, and at each end of the sheet we can't turn them up and down like we can a metal sheet, so we put a bead of silicone underneath the bottom of the fiberglass sheet within 25mm, and on the top end of the sheet we set a closed cell profiled infill strip in a bead of sealant. Foot traffic, I touched on this before, it's very important. When you're framing your roof out or right back in your design stage, consider what is going on the roof, who's going to be going up there, how much roof traffic you're going to get, are you putting solar on it, If you are, then we need to consider not your batten spacings and your support framing, not just for wind loading, but also for roof traffic. This guide here is the only one that I'm aware of in existence. It's put out by Stramit, and it gives you some indications there of the different batten spacings for the different profiles to suit high, normal and controlled amounts of roof traffic. Re-roofing and building approval. When roofing works involve the replacement of more than 20% of the existing roof area, a building approval is required. The building approval must be obtained by either the roofing contractor or the property owner. So who's responsible? The roofing contractor should ensure that the quotes and contracts clearly state whether the property owner or the roofing contractor is responsible for obtaining building approval.